Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 3, Section 6, Linear Systems in 3 Variables. So you are graduating from 2 equations and 2 variables into 3 equations with 3 variables. And yes, you do need to solve for all 3 of them. So let's talk about how we do this. In words, you pair up the equations and use elimination to get rid of the same variable from both pairs. So we want to go from 3 equations and 3 variables and bring it down to 2 equations with 2 variables. And then you just proceed as usual. Use your substitution or elimination to solve them. Plug the answers back in to find the other substitute your first answer back into a 2-variable equation, and then after you have 2 of the variables, you go back to one of the 3-variable equations and plug in your 2 answers to find the other one. So it's kind of difficult in words, but let's just look at it as one of these examples. So first thing you need to do is pick a letter that you want to eliminate by checking out the coefficients and making adjustments as needed. So I'm noticing in the x's here, we have a 1, 3, and a 2. These would all have to be 6's, and one of them would have to be negative for us to get rid of the x's. That's a possibility. However, we notice something with the y's here. I have a plus 1y, a minus 1y, and a plus 1y. This is set up perfectly to eliminate the y's. So that's the letter we're going to go after. So if I call this equation 1 and this equation 2 and this equation 3, we're going to add equations 1 and 2 together first. So adding them, 1x and 3x is 4x. The y's are gone, and negative 2 plus 1 is a negative 1z. And then I have negative 9 rather, and 13 is 4. Then I'm going to look at equations 2 and 3, and since I can see ahead of time that the y's are going to be eliminated, I'm going to add these two together. And after I have done so, what I have succeeded in doing is going from 3 equations and 3 variables here down to 2 equations and 2 variables, and now you can proceed as normal, just like you did previously in this chapter. I'm going to multiply this top one by 5 and have the z's cancel. So I'm going to write that there. I have 20x minus 5z equals 20. So now when I add these, I have 25x equals 50. Therefore, x is 2. So now I have one of these answers. I cannot go back yet and use one of these 3 variable equations because I only have one of them. We need to go back up here and look at one of these 2 variable equations, and that's how we're going to find the z, by plugging in this 2. I think I'm just going to look at this top one here and put the 2 right there, and then I'm going to solve for this z. So 2 times 4 is 8. 8 minus z equals 4. So if I bring the z over and bring the 4 over, I get 4 equals z. So now I have 2 of the answers. When you have 2 of them, now you can go over here to one of the 3 variable equations, plug in your x and your z, and find the y. And again, it doesn't matter because all 3 of these are intersecting at this point. So I guess I'm just going to choose the top one, put in the 2 for x. I don't know the y. Put in that 4 for z, so that's going to be times 2, so that's minus 8 equals a negative 9. So to get the y alone, I need to add an 8 and subtract a 2 from both sides. So negative 9 and 8 is negative 1, and a negative 2 is a negative 3. So this is a location on a graph. These, it is a 3-dimensional graph, and so we do put these in alphabetical order to state the location. So we have 2 is the x, negative 3 is the y, and 4 is the z. So that's the solution for 3 equations and 3 variables. All right, now you have the knowledge you need for section 3.6. We have finished chapter 3. Yay! All right, have fun with that.